Hello guys, welcome to another video. Today we're going to continue solving Unit 3, October 2024, question 2. I posted so late despite all the requests. It's because times are uncertain, guys. I don't really find the time to make these videos. And then when I literally do, like just now when I was about to make this video, a spider literally descended from the ceiling via a thread right next to my face. What are the odds, guys? I don't live in a jungle, I promise. But even nature is against me making these videos. Well, anyway, I said I am gonna make this video today, and the spider could not stop me. So here we are. Let's start with question 2. It says a student was given a sealed box that contained some electrical components. The sealed box could contain a diode, resistor, filament bulb, or a combination of any of these components. The student could not see the components inside the sealed box. Two terminals X and Y on the sealed box enabled the student to connect the components to a 6 volts power supply and fixed resistor R. The student investigated the current potential difference characteristics of the sealed box. AI, complete the diagram to show the circuit the student should use for this investigation. Okay, so what's happening? We have a sealed box in which there could be certain components. It's a mystery. It could be a diode. It could be a resistor or a filament bulb or a combination of any of these three. And the student is investigating current potential difference characteristics. Current potential difference characteristics, this word just means like a current potential difference graph. Like the student is going to make that. And how do you make that? You basically measure the voltages in the circuit and the corresponding currents and then plot a graph. So the student is doing this specifically for the sealed box. So they would connect a voltmeter across a sealed box and an ammeter in the circuit and find out a different potential differences and corresponding currents and then plot the graph. The battery that was connected in the circuit was a 6 volts power supply. So in the first question, we just have to draw the circuit diagram that the student would need to draw. So let's draw the battery first. So this is the battery. Okay. So, and then we would, because the student is just measuring the potential difference and the corresponding current, so the only things that we would need would be a voltmeter and an ammeter and a switch to turn on or off the circuit. So here's a switch, and I can place an ammeter here. And the voltmeter, that would be connected in parallel with the sealed box because the student is investigating the current voltage graph for the sealed box. Remember that an ammeter must always be connected in series, and a voltmeter must always be connected in parallel to the component in which, across which you're measuring the voltage. So there you go. That's just the circuit diagram. Moving on to part II. The student was told that the sealed box contained a diode. Mystery solved. We know it's a diode. Explain why the resistor R is needed in the circuit. And it's 3 marks. Again, whenever you're solving a question, look at the marks and write accordingly. You can you can't write more, but never write less. So you have to make sure that you earn all those marks. So the sealed box now has a diode in it. So why is there a resistor? And now, the first thing, guys, why we use resistors in a circuit? The most important reason for which we use resistors in a circuit is to control the current. Resistors are not useless things. They are there to control the current because they oppose current. So if we have resistors in a circuit, uh, we uh, we don't let current reach beyond the allowed value. If like current gets too high, it can burn the things inside the circuit. It can damage the components, which we do not want. So that's why we use a resistor. That's the first thing. But now, what is its connection to a diode? So a diode is basically this thing. This symbol is a diode. And what is a diode? It's a device, an electrical component or device that allows current to flow in one direction only. In one direction only. Um, so the triangle side of the diode, this is positive. The straight line, that's negative. So if you connect a diode like this with a battery, like the positive side of the diode is connected to the positive side and the negative to the negative side, current is able to flow through the diode. But if like you connect the diode in this way with the battery, so now the negative is connected to the positive and the positive is connected to the negative. Now, there will be a negligible current in the circuit, like a very small current. We can almost say there is no current in the circuit. It's so small. The first configuration is called forward biased. The word bias in physics means voltage. So forward biased means forward voltage, which just means positive is connected to positive, negative is connected to negative. The other one is called reverse biased. So now let's get back to the question. Why would there be a resistor when there is a diode in the sieve box? Like, why do we need a resistor? Um, so in forward bias, like current can flow and it can go to a very high value. If voltage reaches a certain value, the current can exceed its value. So current can become high in forward biased. In reversed bias, however, current is negligible. What does that tell you about the resistance? If the current is small, that means the resistance was high. That's why the current is small. So in the reversed biased case, the resistance was high. It's high. That's why the current is negligible. In the forward biased case, the resistance is low. That's why the current is high. And when I'm talking about the resistance, I'm not talking about this one. I'm talking about the diode's resistance. Remember, every electrical component that is used in a circuit has a resistance. Even the battery, uh, the diode, resistors, wires, voltmeters, ammeters, everything has a resistance. But there are certain things that have like negligible resistance, that have so small resistance that we ignore it, we neglect it. So, for example, for an ammeter, we always say it has zero resistance. Or we sometimes neglect the resistance of the battery. It doesn't mean it's not there. Practically, there will be a resistance, but it's small, so we neglect it. And connecting wires, you never take their resistance in your like in the entire physics that you've studied. That does not mean that wires in real life don't have resistance. They have resistance. But but if you're using low resistance wires, we can assume that it's not there. So we assume their resistance is zero. So coming back to the topic, we were talking about resistor, the resistance of the diode. So here we have a diode. Yeah, let me place it here. Um, so what did we discuss up till now? In forward bias, the current can become very high. This means the resistance of the diode is low. In reverse biased, current is very small. That means the resistance of the diode is very high. Now, why do we need a resistor in the circuit? Because when the diode is forward biased, like as shown in the diagram right now, the diode is forward biased. The current, the resistance of the diode at this time is low. So the current will be very high in the circuit. If we do not use another resistor in the circuit, what will happen? The current will exceed the allowed value and damage the components. So that's why we're using the resistor here. So let's write down the answer. The resistor limits the amount of current in the circuit uh, because when the diode is forward biased, its its resistance is very low and current can become very high and damage the diode or the circuit. So the resistor R limits this current. There you go. That's the answer to part 2. Um, moving on to part 3. The student had a choice of resistors to use for the resistor R as shown in the table. Okay, so there is a mystery after mystery. Now we have like 4 choices. There could be any one of these. So there are 4 resistors that could be there in place of R. 2 of them have the same resistances, and then 2 of them again have the same resistances. And we are also told the maximum power. Again, 2 of them have the same power, and 2 of them have the same power. The student was told that when the potential difference across the sealed box is 0.7 volts, the current must not exceed 200 milliamps. Whenever you're reading a question, you must always read it very carefully. Because if you just read potential difference, you might think, oh, that's the potential difference across the resistor or something. You must read the whole thing. It's just across the sealed box. It's 0.7 volts. I'll just draw the circuit here. So this is a diode, and this is the resistor, the ammeter, and this is the voltmeter. So we are told that the potential difference across the sealed box is 0.7 volts. So this is the potential difference here. From the first part, we already know that the voltage of the battery, that was 6 volts. So the current's maximum limit is given to us, that is 200 milliamps. So So we know the two voltages, and since it's a series circuit, the voltages across the diode and the resistor will be different, and they'll add up to the total 6 volts. So the voltage across the resistor will just be 6 minus 0.7, which would be 5.3 volts. So that's the voltage across the resistor. 6 minus 0.7 is equal to 5.3 volts. We're told the maximum allowed current is 200 milliamps. So using that, we can find the resistance of the resistor. So using the Ohm's law, which is V is equal to I times R, 5.3 is equal to 200 milliamps. Milli is 10 minus 3 times R. So R will be equal to 26.5 ohms. That's the resistance of the resistor. So now don't worry, like if you get this answer and then you're like, oh, but that's none of the allowed resistances. So it's fine because the resistances given, like they are the maximum resistance allowed for a certain resistor. So for example, 26.5 is greater than 18, so it's definitely not option A or B because the resistance of the resistor is 26.5, approximately 27, so it's not A or B. So we are left with C or D. Now we've defined the maximum power. So using this resistance, we can find the power across the resistor. So power has 3 formulas. They're in the formula sheet. Whenever you're solving physics questions, you must always have the formula sheet in front of you. Just print it or use a PDF because you shouldn't in the exam you shouldn't just be looking for, oh, where is that formula, and then in that exam pressure you'll not be able to find some formula. So you should just know where a certain formula is located. That's how much you should practice with the formula sheet. So power has 3 formulas, like there is current times voltage, there is voltage squared over resistance, there is current squared times resistance. We have the voltage across the resistor. We have its resistance too, like 26.5. We can use this formula. We could also use this one. That's fine. We could also use this one. It's fine. So let's use power is equal to V squared over R. So 26.5 squared, sorry, that's the resistance. V squared, that's 5.3. 5.3 squared over the resistance, which is 26.5. So that gives me 1.06 watts. So this is the power for the 26.5 ohms resistor we're using. So now look at the two options that we are left with. We have 0.5 watts and 2 watts. So 1.06 exceeds 0.5. So it's definitely resistor D. So since the resistance 26.5 is greater than both A and B, and the power exceeds 0.5 watts. So the correct answer is resistor T. So that's how you do this. I hope that's clear. Moving on to part B. The student plotted the graph below. So finally, the student is doing what he was supposed to do. Current potential difference characteristics or current potential difference graph. Uh, so the graph looks a bit strange because you might not have looked at such a graph in the four graphs that you've studied, like the resistor, diode, filament lamp, and thermistor. So an important point to mention here is the graph of a resistor. Because a resistor is an ohmic device, like it has a constant resistance, its graph is a straight line that passes through the origin. And the second thing that we are dealing with here is a diode. A diode is a non-ohmic device. So it's in its forward bias region, its current can, after certain value of voltage, it increases rapidly. Uh, but in its reverse bias region, sorry, let me correct this a bit. In its reverse bias region, it's very small. So you might even see this graph just like looking like this. Like it's literally lies on the x-axis, and then over here it suddenly rises. So that's because in reverse bias, it's a very small current, so we almost take it to be zero. Um, so these are the two graphs to keep in mind while solving this question. Now how do I know what I should think of these graphs? Because there's a graph that looks pretty weird. This region of the graph, it looks like a diode, but the other region, that looks like a resistor's graph. So that's why your mind should go to the graphs. The sealed box contained a diode and a resistor. Okay, now there are two things in the sealed box. The diode and resistor were either connected in series or connected in parallel as shown below. Explain whether the diode and resistor were connected in series or in parallel. 2 marks. There are two things in the sealed box, and we have to say whether they're in series or in parallel. So, if they were in series, the current in them would be the same, like, because in series the current is the same, but the voltage is different. In parallel, the current is different and voltage is the same. So if you look at the graph, first let's look at the negative part of the graph. So the negative part is basically the reverse biased region. Okay, like if you're thinking why are there negative voltages and negative currents, that basically just means that the diode is connected in reverse biased with the battery. So like you've connected the negative part of the diode to the positive part of the battery. Now in reverse bias, this is a reverse bias. The graph looks like that of a resistor. It does not look like that of a diode. That's the first thing. So we'll write it down here that the graph in the reverse biased region looks like that of a resistor. Now, recall what we said when we were doing that question, like why is a resistor needed? We said that in reverse biased, the current is low and the resistance is high. And the current is not low, like just low. It's so low that you can almost consider it to be zero. That's how low the current is. But in the reverse biased part here, there is current flowing. Look at the values of current. It's minus 50, minus 100, minus 150, minus 200 milliamps. The current is increasing. And it's negative just because of the reverse bias thing. So what does that tell you? The current is increasing. So the reverse biased behavior of the diode is not dominant here. It's the resistor that's working. Now, if the two things were connected in series and the diode was reverse biased, okay, let's just draw a diagram here to like make it easier to understand. So let's say this is the diagram. So negative, positive, positive, negative, reverse biased. If this was in reverse biased, the diode would have a very high resistance and no current would flow, or a negligible current would flow. So the graph would look like what? The graph would look like this, or it would literally lie on this line. I would just draw one of them so you're not confused. So that it would literally look like this. But it doesn't look like that. This means that the two components were not in series. They were in parallel, because only in parallel circuits, current has the ability to go to another path because there are multiple paths available. So in parallel, again, let's say they were connected in reverse biased. So when the current would travel up till this point, the diode, this path has a very high resistance, so high that no current would pass. So the current would take the low resistance path and will go here. So that's why you would get a resistor graph here. So parallel is the answer. And then if you're wondering what happened on the forward bias side, so when it would be forward, okay, just to explain that, when it would be forward, like this. Now, among the resistor and the diode now has low resistance, and current takes low resistance path. There would still be some current going through the resistor, but it would be much less compared to the one that's going through the diode. So the diode characteristics would become dominant, and that's why the graph here looks like that of a diode and not that of a resistor. So we'll say the graph in the reverse bias region looks like that of a resistor, which means no current was flowing through the diode. Or I would just rephrase it. This sounds a bit strange. So I would say the graph in the negative region Looks like that of a resistor because the diode in reverse biased has a very high resistance. So current flows through the resistor instead. And its characteristics become dominant. The word characteristics here means graph. For this to happen, both components must be in parallel. Because why? Again, if they were in series and the circuit was reverse biased, there would be no current flowing. The graph would look like that of a diode because the diode would have a much higher resistance than the other resistor. So I hope that's clear. We'll move on to question 3 in the next video. And see you next time, guys. Take care. Bye.